electric spring-applied brakes. Electric or electromagnetic direct current single-disc spring-set brakes are the most common type of holding brake produced. Electromagnetic spring-applied brakes are designed to stop and hold a rotating shaft or to simply hold the shaft in place. Their function is opposite from a traditional electromagnetic brake. When no electric power is going to the brake is considered engaged and holding. The two main reasons for using these brakes are safety and accuracy. Common applications include medical equipment, robotics, factory automation, servo and stepper motors, elevators and escalators. The key components to the brake are the coil, springs, pressure plate, friction disc, cover plate, and hub. Spring-applied brakes transmit torque via spring pressure and use an electromagnetic field to release the spring pressure. Brakes are engaged mechanically and disengaged electrically. When voltage or current is applied to the brake, the coil becomes an electromagnet. This produces magnetic lines of flux. This flux travels through the small air gap between the pressure plate and the field coil, attracting the pressure plate to the coil and compressing the springs, releasing the friction disc so it is able to rotate. When power is removed from the coil, the pressure plate is released and the springs push the pressure plate against the friction disc, trapping it between the pressure plate and the outer brake cover plate. Since the hub is attached to the friction disc, the hub and the shaft going through the hub are either dynamically stopped or held in place. The difference between the two is that during dynamic stopping, heat is generated, so the brake and friction material have to be sized to handle the energy during braking. With a holding-only application, only the static torque needs to be considered. Depending on the brake and its function, different types of friction material can be used. In most applications, the friction material is free to move over a square or spline on a hub that is fixed to the shaft. There is a slight clearance or backlash between the hub and the friction disc. For zero backlash applications, the hub is directly connected to the spring steel disc. In these types of brakes, when the friction discs are held, there is no backlash movement at all. Backlash can be critical in high-precision applications like medical equipment or microchip processing. Brake coils are normally 90 or 24 volts, but there is a wide variety of specialty voltages available. Different controls can also be used with holding brakes. Over-excitation can provide a faster response. For power savings, reduced current controls are available. Since most of the current is required to reach across the air gap to the pressure plate, once the pressure plate is engaged, current can be reduced significantly to reduce power consumption of the brake.